What is object-oriented programming? Object-oriented programming, or OOP for short, is a way of programming that utilizes the concept of objects and classes. It provides a method of structuring data into pieces of reusable code known as classes that multiple objects can be created from. By using this method, more complex code can be organized in a way that is more efficient and manageable than that of the traditional method of procedural programming, in which a program is run in order line by line. Object-oriented design is a way of designing your software so that objects are treated as if they had qualities, abilities, and limitations. Classes and objects in OOP. A class in OOP can be described as a design or blueprint containing attributes and methods. It gives the set of instructions required to construct a specific type of object. When an object is created from a class, this becomes an instance of the class, and we can make as many instances of a class as we require. A class is user-defined layout or blueprint of an object that describes what a specific kind of object will look like. Examples of class and objects. Here we can see a human class containing its properties. These are its variables, which are name, age, and sex, and its methods, walk and sleep. From this human class, we have created two objects, which are instances of this class. Each of these objects contain their individual variables, name, age, and sex, and the methods walk and eat. The four principles of OOP. There are four key principles of OOP. Inheritance. Inheritance is a word that consists of the word inherit, which means to derive. So inheritance is defined as one class's tendency to derive properties and characteristics from other classes. Encapsulation, by definition, is the process of hiding an object's implementation from another object or program while presenting an interface that should be visible. Abstraction. Its main goal is to handle complexity by hiding unnecessary details from the user. And polymorphism refers to the ability of a variable, function, or object to take on multiple forms. Inheritance. Inheritance allows properties of a class to be acquired by another class. Classes are organized in an order of hierarchy to ensure duplication of code is avoided and to reduce redundancy and support reusability. In a parent class, we can define basic behaviors and attributes. From that, a child class can be created, inheriting the functionality of the parent class with the addition of extra behaviors and attributes. Inheritance promotes reusability. When a class inherits or derives another class, it can access all the functionality of inherited class. Example of inheritance. Here we can see an employee parent class, also known as base or superclass. From this class, we have two child classes, which are also known as derived or subclasses. These two child classes, full-time employee and part-time employee, inherit from the parent class, but also include their own attributes and methods. How to implement inheritance. Here we can see the parent class person with attributes and methods. Over here we can see the teacher class inherits from the person class the attributes name and age, but also adds an additional attribute of department. Abstraction. The main goal of abstraction is to hide complex code from the user. Abstraction provides a method of hiding the implementation of the code from the user. By providing abstract classes to users, this will allow the complex and implementation code to remain hidden. Objects, also known as instances, cannot be created from an abstract class. However, this abstract class can be used to provide a base for other classes from which objects can then be created. When used correctly, abstraction can help to make an app or program more secure, more maintainable, and more modular. Abstraction in object-oriented programming helps to reduce the complexity, the design, and the implementation process of software. Example of abstraction. Here we can see we have made an abstract class person using the keyword abstract. As this is an abstract class, no objects can be created from this. We can only create other classes. Here we see if we try to create a person object from the person class, we'll get an error. Encapsulation. Encapsulation allows data to be kept safe and provide access to data or functions within a class by way of methods. We use keywords private and public when defining classes to determine the access of these classes. Private means properties and methods can be accessed by methods of the same class, while public, the methods and properties can be also accessed from outside of the class. Using encapsulation prevents unwanted changes to data. Example of encapsulation. In this person class, we have set the variable name and age to private. Now, if we want to modify or read the variable, we must implement get and set methods. Here, the get name and get age are implemented to read the variables stored. Polymorphism. Polymorphy means many forms. In OOP programming, polymorphism is ability of an object to take on many forms. This concept provides a method for performing the same action in different ways. We may have a parent class with a method that performs a certain task, but a child class can override that method to perform its own task. It allows programmers to reuse, evaluate, and execute the program module's forms written once. In certain aspects, they can be repeated. This is an example of polymorphism. Here we can see a parent class person is created with a method called getRole. We create the child class teacher from the parent class, which also has a getRole method. However, we put the keyword override. Now, when we create a teacher object from the teacher class, the teacher getRole method is implemented with the result I am teacher printed to the screen, rather than the I am person line from the getRole method in the person class. Why use OOP? There are many advantages of using OOP, therefore making it a far more efficient way of writing programs. The reusability inheritance provides means there is no need to retype code again and again. Security of code provided by the abstraction method, keeping complex code hidden. OOP allows effective problem solving with the code being broken down into smaller solvable problems. The flexibility provided by polymorphism allows methods to adjust to whichever class they are in. Troubleshooting is made easier as you know exactly where to look for the problem. With encapsulation, keeping objects self-contained, ensuring functions do what they should without interfering with other functions.